Hi guys, I'm going to talk to you about when to use the n+1 versus the n when it comes to the stuff to do with the median and the quartiles, okay? So basically, to cut a long story short, if you've only got a minute and you need to like rush off, to cut a long story short, the n+1 over 4 and the n+1 over 2 and the three lots of n+1 over 4 you only use it when you have a list of numbers or you have a frequency table that is not grouped. Okay, as soon as you have a grouped frequency table and it's asking you to estimate the median or it's asking you to estimate the quartiles, you do not use n+1 in that situation. Okay, you do not use n+1 in that situation. Now, I'm going to show you here how we use the n+1 formulas when we have a list of numbers and how that works. It's going to give us the same as with kind of the classical approach at GCSE, which I will actually start with. Okay, so we're gonna do these 4 examples. You can follow along. You can get some paper. You can write it out yourselves, and you can compare methods and see that most of the time it gives the same. And I will also talk a little bit about what you're allowed to do in the exam. Okay, so first of all, example 1, classical approach back at GCSE. To find the median, you'd cross off from either side until you got to the middle, and then there you go, there's the middle, right? So your median for this one is 9, and then to get the quartiles, now the quartiles is where there's a little bit of controversy. If you actually look at Wikipedia and you type in quartile on Wikipedia, it actually tells you there is no kind of universally agreed upon method for calculating quartiles. Okay, so there isn't the method back at GCSE is not wrong. It's not a wrong method. The method in the book is not a wrong method, but sometimes they can produce different results. It's going to turn out that in the exam, as long as you're consistent with the method that you go with, it would allow for any of the methods that you could use. Now, the 2 main ones are the one that I'm about to do here, which is the one taught at GCSE, and it's also the one from the textbook, right? So I will talk about both in this video, and then that's what this video is going to be. Okay, so anyway, classic approach from GCSE is go to the middle, that's your median, and then cut the data in half through the median into a bottom half and a top half. The lower quartile is the median of the top of the bottom, and the upper quartile is the median of the top. Okay, so halfway between 5 and 8 is 6.5, and halfway between 13 and 18 is 15.5. So if I write down the values we have 6.5, we have 9, and we have 15.5. So this is what we would get if we followed the sort of approach that we were taught at GCSE. Okay, if we do the same here, halfway is halfway between 17 and 18, which is 17.5. And then this would be the lower quartile, and this would be the upper quartile. So we've got 14 and 22. Now it turns out it's this example here where you would get slightly different answers for your quartiles if you use the method in the book. Now I'll get onto that soon. Right, for example 3, there's your median, and then there's your lower half and upper half. So there's the bottom half's median, the top half's median. So that's actually kind of your easiest situation. So that's 6, 8, and 14. And then last one, we've got halfway between 15 and 17, which is 16. We've got halfway between 10 and 11, which is 10.5. And we've got halfway between 19 and 21, which is 20. Okay, so these are the answers you would get for the lower quartile, median, upper quartile for this method taught at GCSE, and also the first method that's talked about on Wikipedia. It's also my preferred method. I think it's the best method. It's the one that I think that we should be using. However, the one in the book gives you a formula for locating whereabouts the quartiles should be. So quartile 1 is located, so if you've got n data points, so this is n data points, so this will be n is 5, this will be n is 6, this will be n is 7, and this is n is 8. So the median, which is Q2, is 2 lots of n+1 over 4. In the book, of course, you'll see that as just n+1 over 2 because it's 2 quarters is the same as a half. And Q3 is 3 lots of n+1 over 4. Now, the equals, it's not really a particularly precise equals because it's really just telling you whereabouts to look. And the idea is this strategy. What's the idea? If you get a whole number, then that is how far along you need to go, and then there you go, that's it, that's what it is. So if the answer was 5, you would go to the 5th number and that would be it. If the answer to one of these is a decimal, and since we're dividing by 4, the decimal would either end 0.25, 0.5 or 0.75. No matter what the decimal ends with, you go halfway between. So if it was 2.25, that's between 2 and 3, so you go halfway between the 2nd and 3rd number. If it was 9.5, that's between 9 and 10, you go halfway between the 9th and 10th number. If it was 17.75, that's between 17 and 18, so you'd go halfway between the 17th and 18th number. And what you'll find is you actually get the same answer as this classical GCSE approach most of the time. Okay, most of the time. So I'm going to show you me using this formula for these different examples and see that most of the time we get the same answer, right? So let's do the first quartile for example 1. So it's the first quartile, so I put a 1 there. Obviously, I know that you don't really need to put the 1 there. I'm just putting it there for emphasis, basically. And then it's 5 numbers, so the n is 5, so it's 5 plus 1 goes in the brackets there. And then I'm quartering that. So this is between 1 and 2, so it's halfway between the first and the second number. So halfway between the first and the second number is halfway between 5 and 8, which is 6.5. So we agree with that, which is good. The advantage of using the formulas in this written like this is you can just change the 1 to a 2 and just change the 2 to a 3. It's just quite quick if you do that. So anyway, for the median, it's the 3rd number along, which is of course 9. And then finally, if we change that 2 into a 3, we'll get the 3rd quartile. So what's really important to remember is the 3rd quartile isn't 4.5. This is telling you where to look. It's telling you to look between the 4th and the 5th number. So we'll go to the 4th and the 5th number, and we have to go halfway between them, which is 15.5. So it actually totally matches up with the original GCSE approach. Now the advantage to these formulas, by the way, is simply that if n is 1,306,413, I've already forgotten what number I said, and you're asked whereabouts is the median and whereabouts are the quartiles, you can actually use this formula very, very quickly and not have to worry about writing loads of numbers out and counting along, right? That's the advantage of this. But this is just one of many strategies to locate the quartiles in a list of numbers, okay? You might have a different textbook that you've bought yourself that actually uses a different method. There's a method that does n on 4, 2n on 4, and 3n on 4, and then asks, and then you have to do something slightly different depending on what the answer is. This is not the one and only method. And there are other methods that would produce different answers yet again. So you need to basically, since it's taught in the book, And since this red method is, what everyone inherits from GCSE, you need to know both of these. You need to know them both, and you need to be comfortable with both. And you also need to know that it doesn't matter which one you use in the exam. Doesn't matter, as long as you're consistent. So anyway, what happens when n is 6? So as I've already kind of suggested, when n is 6, you get a problem, right? You don't get the same answer as with the original red numbers here. So let's try it. If I look for the first quartile, so 1.75, now remember, that is between 1 and 2, so I've got to go halfway between the first and the second number. So halfway between 12 and 14 is actually 13, which is not 14. For the median, you go halfway between the third and the fourth, which does actually give you 17.5, so that's good, matches up that one. And then if we do the upper quartile, you get 5.25, so it's halfway between the fifth and the sixth. So it's halfway between 22 and 31. Now 22 add 31 is 53, half of that is 26.5. So anyway, what the idea here is, look, it's not giving you the same. So it's like, is one of them wrong, or is one of them right, or could you use both? Well, there's, as I said earlier, there's not a universally agreed upon method. Okay, if you put 14 and 26.5, you'd be wrong. If you put 13 and 22, you'd be wrong. You need to be consistent with whatever method it is you've picked. Okay, so if 14 is your lower quartile, then 22 is your upper quartile. And if 13 is your lower quartile, then 26.5 would have to be your upper quartile. Now, the reason I'm pointing this out is because most people learn to work out the quartiles from GCSE and from the method of, split the data in half with the median, go at the lower half, go at the upper half, and work out the medians there, right? And if you do that, you get 14 and 22. If you follow the instructions in this book, and if you answer a question like this in the book, and there is a question like this, where n is 2 more than a multiple of 4, if you got this question in the book, the answer at the back would be 13 and 26.5. So to be clear, that's not to say that 14 and 22 are wrong. It's just not the method that the book is using. The method you use in the exam is either of these methods. Just be consistent. Now, I'm actually not going to bother with the n is 7 and n is 8 case. It turns out you'll get 6, 8, and 14 in blue, and then 10.5, 16, and 20 in blue. The only time that you don't get the same answer anyway is if you have 2 more than a multiple of 4. So that could be 2, 6, 10, 14, etc. data points. In that situation, you will get different lower quartile and different upper quartile depending on the method that you have picked. Okay? So that's really all you need to be aware of, okay? There's not a right and a wrong, you just need to be consistent. I know that when I originally talked about this right the way back before Christmas, I want to say, was it? I can't remember. Was it just before Christmas? Well, anyway, when I did the lesson in class, about this, I said, if you want the blue approach to give you the same as the red numbers, then one little thing that you can do is check before you start what sort of n do you have, and if it's 2 more than a multiple of 4, then for the quartiles you round your answer. Now that would just give you the same as the red numbers. If you applied that, you would get 14 and 22. Right? Let me just point that out to you. So do you notice if you round 5.25, it would round down to 5, and the fifth number is 22. And if you did this with the first, that would round up to 2, so it'll give you the second number, which is 14. Now, All the other times, you don't do any rounding. Only in this exact situation, and this is if you want it to give you the same as if you were using the classical GCSE approach, is when you round. Okay? You don't even have to, though. You can just stick with the blue answers. You can stick with the blue answers. Okay? The exam will not care which one you pick. All right? So that's it, basically. That's the only time you're going to worry about this n+1 business. Okay? As soon as I give you a group table, whether it's discrete data or continuous data that has been rounded, if it's in a table and it's grouped, and this is really important, it's got to be grouped. If it's not grouped, then you for all intents and purposes do have this situation. So what I mean is, if it wasn't grouped, you might have like 1, 2, 3, 4, 5, 6, and then all the frequencies underneath. There's no actual groupings. There's no actual groupings. In that situation, you would still be permitted to use this n+1 approach, okay, to figure out whereabouts is the median, whereabouts are the quartiles. When you have a grouped table, so I'm talking about something that looks like this or something that looks like this, the n+1 stuff just doesn't, you just don't even use it anymore. Don't use it. It's not relevant, okay? You use n, not n+1, and if it's discrete, you use what's called a continuity correction. A continuity correction. So you would round this, you would make this 1 be 0.5 up to 2.5. This 3 would become 2.5 up to 5.5, etc. Okay? And even then, and I don't want this video to get too complicated, it would depend on the nature of how you would want it to be rounded. So what I mean is it might not always be 0.5 up or down. If these were ages, what would the continuity correction look like then? It would look like 1 up to 3. It would look like 3 up to 6. It would look like 6 up to 11. And it would look like 11 up to 21. And that's because someone is considered 2 years old right the way up until the day before they're finally considered to be 3. So there's this sort of layer of complication added on top. Now I'll address that in more detail in a different video. I just wanted to make this video to make it really clear, or try to make it really clear, when you use n+1, and it's only when you have or could generate a full list of numbers. Maybe it's a huge amount of numbers, maybe it's like 1,000 numbers, but you could do that. And if you can do that because it's not group data, then you're allowed to use this n+1 formula thing, okay? Right, I hope that that's helped. I will produce another video that talks about estimating the median and quartiles where we've got group data. But just as long as you remember to only use this n+1 thing when it's a list of numbers, and even then you could get away without ever doing that, because you can use the old-fashioned approach, which of course has the drawback of, if it's a huge amount of numbers, you'd need some method to work out exactly whereabouts the quartiles and the median are. Right then. Any questions? If I've made anything more complicated than it needs to be, or you now don't understand something whereas you thought you did before, please send me an email. Please ask me to clarify things, and I will absolutely happily get back to you. Right. Thank you. Bye-bye.